Right, so in this video I'm just going to have a look at dividing a line segment into a given ratio. Now we're going to divide line segments into a ratio internally and externally. So let me just run through that. Our formula is going to be this one here, and our line segment here in this particular case is going from A to B. Now A has coordinates x1, y1, B has coordinates x2, y2, and we're going to look for the coordinates of OR, which divide it divides the line segment AB in the ratio small a to small b. So this here will give us the coordinates. This will give us our x value, and this will give us our y coordinate of OR. So really it's just b times, so this part here times x1, this is our x1 here, plus a times x2, all divided by b plus a. And this is the same here, but it has our y coordinates here. So this divides internally, so it's the point OR will be somewhere between the point A and B. Now externally then is this formula here. It's exactly the same as the first formula, except for these negatives here. You have a minus b and a minus b here, you've got a minus b and a minus b here. Other than that, it's exactly the same, but the point OR will appear outside the line segment PQ, but on the same line if you like. So if you continue that line on, OR will be somewhere out here, but it will be outside the line segment PQ. Now again, P has coordinates x1, y1, Q has coordinates x2, y2. A will go from here out to OR, and then B will go from OR to Q. And that's it. So I'm just going to do a basic example first. I have it done out here, so I'll just run you through it. We're going to take A with coordinates 1 minus 2. So 1 minus 2, we're going to call it x1, y1. B has coordinates minus 4, 8, which has coordinates x2, or which we'll call x2, y2. And we're going to look for C, which is somewhere in the middle here. And we're going to divide, C is going to divide the line segment AB in the ratio 3 to 2. Now we're going to just do this internally first, and then I'll do it externally. So I've written the formula down here, the internal division formula down here, and I've identified all the numbers we need to put into it. So B here is 2, so we put in 2 here. x1 is 1, A here is 3, this is A, and so on, A plus B down at the bottom here. You do the same over here, multiply all of this out, and you get minus 2, 4. So in other words, I've just drawn it here. If this is A, this is a rough sketch. If this is A and this is B, our point minus 2, 4 will be somewhere here in the middle, and it divides the line segment AB in the ratio 3 to 2. And that's it really. I've done it again here, but just dividing the line segment AB externally. So in other words, I'm going to look for the coordinates of some point up around here somewhere that will divide the line segments AB externally. So in other words, A up to the point C up here somewhere will be 3, and then back here will be 2, so it'll be 3 units divided externally in the ratio 3 to 2. So again, I've written everything down. I've written the formula down here, so it's minus b times x1 plus ax2 over minus b plus a this time, and the same, you've got a minus b and a minus b here. Other than that, it's exactly the same. So I've identified each of our numbers here. So this is x1, y1, this is x2, y2, and we want to divide in the ratio 3 to 2 externally. So 3 is A, 2 is B. Put the numbers in. So it's going to be minus B, so it's going to be minus 2 times x1, which is 1, plus A, which is 3, times x2, which is minus 4, all over B plus A. So it's it's minus B plus A, I should say. So it's minus 2 plus 3. Same thing over here, you do exactly the same thing again, but this time you're using the y values, the y coordinates, y1 and y2. Just multiply all that out, so you've got you end up with minus 2 minus 12 over 1, and 4 plus 24 over 1, which reduces down, simplifies down to minus 1428. So minus 1428, if we look at our diagram here, it's going to be somewhere way up here. So in other words, minus 1428 will be dividing the line segment AB externally in the ratio 3 to 2. Okay, so there are two fairly straightforward examples. It's just writing the formula down. You have 2 points, you have your ratio, identify each number and then put them into the formula. It will give you the coordinate of the point that divides the line segment in whatever ratio you were given. Okay, so let's look at another example. Now this one is a little bit different. It's a little bit more detailed, but it uses this formula again. So what we've got here is we've got 2 points. We've got the point A and the point B, and we have this line here, 6x minus 8y minus 71 equal to 0. Now the question is, in what ratio does this line here divide the line segment AB? So in other words, I've drawn a rough sketch here. So we have A here, let's say, and B here. This is our line segment AB. And this is our line, and it cuts through the middle of the line segment, or somewhere it cuts the line segment AB. Now what we have to find is the ratio A to B here. What is this ratio that this line here divides the line segment AB into? So we got to work out what A is and work out what B is. Small a and small b. We've got to work out this ratio. Okay, so generally what we're going to do here is we're going to try and find the coordinate of this point of intersection of these two lines. So I got to work out the coordinates of this point here. So how do I do that? Well, to find the point of intersection of two lines, what we normally do is we use simultaneous equations. So we have the equation of our line, or one line anyway, this white line here, but we don't have the equation of this line. So what I'm going to do is I'm going to use these points here, these numbers here, to find the equation of this red line here. Once I find the equation of this red line here, I'm going to use simultaneous equations to work out the point of intersection, this point here. So let's start then. First thing we're going to do is we're going to work out the slope. We have to work out the slope of this line, because remember, we're going to use this formula here to find the equation of this red line. In order to use this equation here, we need two things. We need a point, x1 and x1, y1. We have 2 points to choose from, so I can use either one of these. But we also need the slope. We don't have the slope of this red line, so we got to use the slope formula. So remember, our slope formula is this one here. It's the difference of our y's over the difference of our x's, or rise over wrong, or tan, whatever way you want to look at it. But it's this formula here. So we're going to call, let's say we'll call this x1, y1, x2, y2. Let's stick those in here. So we have y2, so that's going to be minus 2, minus 6, so that's plus 6, all over x2, which is 5, minus x1, which is 8. That gives me a slope of minus 2 plus 6, which is 4. 5 minus 8 is minus 3, so it gives me a slope of minus 4 over 3. Okay, so now let's just put, I'm going to use this point. I'm going to use this point in my formula here. So I'm going to use A in my formula for the equation of a line, and this slope here. So let's do all of that. So we have y minus 6, so that's plus 6, is equal to our slope, which is minus 4 over 3. We've got x minus 8. So there's the equation of my red line. So let's just multiply across by 3 here. So we get 3y plus 3 6s 18 is equal to minus 4x plus 4 8s 32. Let's see, we'll bring everything over to one side. So we'll say 4x plus 3y, and we have a plus 18 minus 32, and that will give me minus 14, I think it is, equal to 0. Okay, so I'm going to call this equation 1, and we'll put the other equation underneath it, and that one was the one we were given in the question, so that was 6x minus 8y minus 71 equal to 0. So I think what I'll do here is we want to find the point of intersection of these two lines. So I think what I'll do is I'll take equation 1 first of all, we'll take equation 1 and I'll multiply that by, I'm going to try and eliminate these x's, so I'm going to want to make these into, let's say, 12. So I'm going to multiply equation 1 by 3 and equation 2 by 2. So here we will get 3 fourths 12x plus 9y minus 42 is equal to 0. Our second equation here we're going to multiply by 2, so that's going to be 12x as well. We have minus 8 16, and then we have minus 71 142 equal to 0. So what I'm going to do here is subtract both of these, okay? So if I subtract, that becomes 0. So it's 9 plus 16, so that just becomes 25y. Here I end up with plus 142 minus 42, so that gives me plus 100, that gives me 0 here. So that just gives me y here equal to, let's see, that's minus 100 divided by 25, so that just gives me minus 4. Okay, so let me just substitute that into one of these equations here. So let's say we'll take this one here. 4x minus 3 times y, well we know y is minus 4, minus 14 equal to 0, so that gives me 4x. That gives me plus 3 fourths 12 minus 14 equals 0. Let me see, am I right so far? I got that right. 4x, oh sorry, this should be plus 3y, and that's minus 14, so yeah, that makes more sense. So let me just change that. Okay, so let's see, we have minus 12, is that correct? Minus 12 minus 14. Okay, so here we end up with 4x minus 14, 24, 26 equal to 0, so we end up with 4x equal to 26, so that gives me x is equal to 26 over 4, or just x is equal to 13 over 2. Okay, so we have our point of intersection. So our point of intersection is, let's see, 13 over 2 and minus 4 here. Okay, so we have the point of intersection of our two lines. Now, there are a couple of ways of proceeding from here, but what I can do is use the formula and use some kind of simultaneous equations here to work out what a and b are. But I'll just use the translations first, translation way of doing this. If you take a here, a was, remember, 8 minus 6. C was 13 over 2 minus 4. This was our point of intersection here. And on the other end of our line segment we had B, and the B was 5 minus 2. 5 minus 2. Now, this point is in the middle here internally between A and B. So if we have a look at this, what would we need to do here to go from A to, we'll call this C here, we'll call this C. What do we need to do to go from A to C here? Well, we want to go from 8 to 13 over 2. Well, 8 is, let's see, we would actually have to subtract 3 over 2. Subtract 3 over 2. Because if you think about it, 8 is 16 over 2. 8 would be 16 over 2, so 8 is just the same as 16 over 2. And we want to go from 16 over 2 to 13 over 2. So to go from 16 over 2 to 13 over 2, we would have to subtract 3 over 2. Now how would we go from minus 6 to minus 4? Well, we would just add 2. Okay, so now we're at C. How do we go from C to B then? Well, we want to go from 13 over 2 to 5. Well, what's 5 as something over 2? Well, 5 would be 10 over 2. So if we take 5 here, that's just 10 over 2. Now remember, we're going from 13 over 2 to 10 over 2, or just 5, so we would have to subtract 3 over 2. How do we go from minus 4 to minus 2? The y coordinates. From minus 4 to minus 2, we would have to add 2. So if you look at this, to go from A to C, we have to subtract minus 3 over 2 and add 2. To go from C to B, we have to do exactly the same thing again. Minus 3 over 2 for the x and add 2 to the y. So the ratio then, this must be exactly in the middle. So our ratio here must be just simply 1 to 1. So this would be our A and this would be our B, if you like, our small a and our small b. That's one way of doing it. I mean, you can use the formula as well. It's a little bit more detailed, but I'll just quickly run through it. If you take our coordinate was our point in the middle that's dividing AB is 3 over, it's going to be 13 over 2 minus 4. That was the point in the middle. So really we could say 13 over 2 is going to be equal to 8b plus 5a over a plus b. This is using part of the left hand side, or the x coordinate of our formula. Our y coordinate then, our minus 4 then would just simply be equal to minus 6b minus 2a all over a plus b. So what you could do is just multiply these out and do some kind of simultaneous equations to work out a and b. But however, if you look at this part here, if you multiply across here by a plus b, you get minus 4a minus 4b is equal to minus 6b minus 2a. Let's see, that will give me, bring this minus 4a over here, or add 4a to both sides. You'll get 2a on this side. Add 6b to this side, add 6b to this side, and you get 2b on this side. So really you get b is equal to a. b is equal to a. So that will just tell me that the ratio must be 1 to 1. If a and b are equal, the ratio must be 1 to 1. So that's another way of doing it. But this translation way up here is a little bit easier, I think. Okay, so that's it for dividing a line segment into a particular ratio using that particular formula.